Buildings are huge consumers of energy, 70% of the electricity in the United States, and as a result, responsible for 48% in the U.S. of carbon emissions that are contributing to climate change. We can make a big difference if we figure out how to change those numbers.
Everyone who's doing this right now is a pioneer in figuring this out.
Oddly, one of the first questions that I got was, do they work? Of course they work.
Anything that's been an innovation in the building industry was like that at the beginning. You needed people to show the way and to show it could work.
When we were going to build this 300,000 square foot facility, we wouldn't build it otherwise. We were planning on building it green.
We've pushed ourselves to the edge of the cliff and we're looking over there going, boy, we really need to change the way we're doing business on this planet.
Technology got us into this problem we're in, and it's going to take technology to get us out.
What do you find when you look at green examples that are out there? The question is, are they modelable?
What are the cost-effective green building measures that have the biggest bang for a buck?
We need to make our mistakes, we need to recognize our successes, and build on that on every project. Every project is a proving ground.
There is no recipe, and that's one of the things that makes it hard, but it's also one of the things that makes it exciting because every project is a creative project. Depending on what you need to use the building for, you'll have a different grab bag of options for making it green.
Aerzen is a manufacturer of large industrial equipment. They needed a new manufacturing plant built and made the commitment to do it as sustainably as they could. What the result was to some people what might look like a conventional assembly plant, but is really quite different. It's naturally daylit and it's passively cooled. These are earth tubes, and we're on the north side of the building, the shady side of the building. What you're looking at is an intake structure for the earth tubes. Air is drawn in, again, from the coolest place on the site, underground, deep underground, where it's cooled even further by the natural coolness of the earth, and brought up into the assembly plant to actually cool the assembly plant for the people that work there. Part of the office building is actually being built using straw bale construction. This building's really out in the farm country of Pennsylvania, and literally within 10 miles of the site, the building materials are being produced. Very low embodied energy, that's the energy that it takes to extract and manufacture materials, and obviously harvesting straw and driving it 10 miles to the site has very little impact in terms of embodied energy. You've got this sort of traditional industrial company that is trying to express their commitment by developing this building that's high performance. It will cost them a fraction of a typical facility like this to operate, and that has a very small environmental footprint.
I think in order for green building and high-performance building to be more of a priority, we need to understand its importance, that we want places to feel better and to perform better, but we also need to use fewer resources to get what we want.